Alright guys, today we're going to talk about inheritance. We're going through chapter 13, skipping chapter 12 for now. Not sure if we'll get back to it. Might be a good thing to read, actually would be, but chapter 13, inheritance, huge concept in Java programming. Particularly the idea of creating an interface and then implementing that interface with your own functionality. So, I strongly recommend reading chapter 13, not just watching a video over it, and then digging into it with external services. Just Google up Java inheritance tutorial or that kind of thing. Read about it. Alright, so prior to this chapter, all of our objects have been relatively simple. Sphere classes, dog classes, that kind of thing. We've been able to describe each object with a single class. But for an object that's more complex, you should consider breaking it up into constituent parts and defining one class as the whole and then other classes as parts of the whole. When a whole class is the owner of the parts classes, then it's called composition. Right? Just like a composition that you write, a musical composition's got choruses and verses and bridges or whatever, or English papers got various paragraphs that make together the whole. You can make a class that contains other classes. So the composition concept is not new. It's what we do to describe complex objects in the real world. Every living creature is composed of individual parts, even a single cell object. Each part is a subsystem that is itself made up of its own set of subparts. So a car is an engine. An engine has, all the various components. The car also has, a wheel system or whatever. So whatever. The whole system forms a composition hierarchy. On the next page, we're going to do a composition hierarchy of a human body. So a composition relationship is one that's known as a has-a. A car has an engine. A car has a, drivetrain, that kind of thing. So a component part is limited to just one owner at a time. You only have one engine per car. You only have one heart per body. Unless you have a conjoined twin. Whatever. A partial composition hierarchy for the human body. You could have a human body. It's got a brain. It's got heart, stomach, bones, muscles. Muscles could also be a part of heart, but let's go on with that. Muscles are composed of cells. Cells have nucleus and mitochondria. The mitochondria is the powerhouse of the cell. The mitochondria is made out of molecules and atoms. So you go from the most singular, the most atomic, the smallest type, all the way up to the type that holds everything. So in a composition hierarchy, the relationships is known as a has-a relationship. Each human body has a brain and has a heart. That's different from an is-a relationship. An is-a relationship. A car is a vehicle. So is a motorcycle. A motorcycle is a vehicle. A person is a student. A person is an employee of the school. That kind of thing. So there's is-a and has-a. It mentions that there's another form of relation called aggregation, which is a weaker form of composition. With aggregation, one class is the whole and other classes are parts of the whole, but there is no additional constraint that requires parts to be exclusively owned by the vehicle. So maybe you have, a bill of sales where somebody bought 2 cars, and that bill of sales is shared between 2 cars. An aggregation example where the parts are not exclusively. You can implement a school as an aggregation. You create a class for the school, and then classes for the different types of people who work and study for the school. The people aren't exclusively owned by the school because a person can be part of more than one aggregation. A person can attend classes at 2 different schools. They can be part of 2 different school aggregations. The same person might even be part of a third aggregation, like a household aggregation. Resisting the urge to try to rush through this. Suppose you're trying to model a car relationship with a computer program. The car dealership is made from several distinct, non-trivial parts. It's a good candidate for being implemented with composition and aggregation. The car dealership's non-trivial parts are the cars it owns, a sales manager, and then the salespeople. So we could define 4 classes: cars, the manager, the salesperson. All 3 of those classes implement the dealership's non-trivial parts. And then the dealership class contains those other 3 classes. For each of those 3 class relationships, dealership to car, dealership to salesperson, and dealership to manager, is the relationship composition or aggregation. Well, can a car be part of more than one dealership? I don't know, if you have a family of dealerships, you know, Owen Johnson Ford and Owen Johnson Used Cars, and either one will sell it to you, I don't know. Salesperson, again, I guess if you own more than one dealership. Same for manager. Not quite sure where they're going with that. But the universal modeling language show the relationships between a program's classes. And we've already done UML where, you know, you listed the name of the class up at the top, and then you listed the methods, and then you listed the data items. I think I have those reversed. The data items were in the middle and the methods were at the bottom. And then you draw lines between your classes in order to indicate the relationship. A dealership has both a car, a manager, and a salesperson. This is saying that a car is the one that can be owned by more than one dealership because it has a solid box. It's a solid line. So on an association line, a solid diamond indicates a composition relationship, and a hollow diamond indicates an aggregation relationship. The diamond goes next to the container class. And to be honest, I think all of my code examples and assignments just assume composition relationships rather than aggregation relationships. I don't think I'm going to make any, you know, classes where the parts can be shared by more than one class. Could be wrong on that. So the diamond goes next to the container class. Dealership contains a manager or references a manager. Wish that would go away. There we go. So since the manager is owned by the dealership, it's part of a dealership, the little diamond shape goes next to dealership. And notice these numbers. One dealership can hold many cars. One dealership can hold one manager. One dealership can hold many salespeople. These are known as multiplicity values. Indicate the number of object instances for each of the 2 connected classes. A star represents any size number, 0 through infinity. So if you were going to list the cars, you might want, you know, an aggregate data, you might want like an array list or something like that, because you could have multiple cars in one dealership. But apparently you can only have one manager per dealership, so you don't need an array list of managers, you just need one manager. Again, you have salespeople though, so you're going to need some kind of container that can hold more than one salesperson inside your dealership. Again, an array or an array list or something like that. I'm not seeing anything that you couldn't glean just by reading the book. You define one class for the whole. You define separate classes for each of the parts. For a class that contains another class, you declare an instance variable holding that class. Typically, for association lines, you use an array list, just like I mentioned. So if you're going to have multiple cars, you're going to need an array list to hold all the cars. You have one manager. Okay. About time to give an example. We're not going to flesh this one out too much, but we will flesh it out just a wee little bit. And I'm not coming up with a cooler example than a car, you know, dealership kind of thing. So let's flesh out what we do. I'm just going to kind of plot out what we need to do. I'm going to want a dealership class. I'm going to want a car class. And you would sit down and you would, draw these out as a UML or whatever. The dealership class is going to have an array list of cars. And then the dealership class and the car class, and we need a manager class. And so not only are we going to have an array list of cars, we're going to have an instance variable, which is a manager. We only need one manager. We don't need a list of managers. I guess if we were doing this differently, we might have made a computer that had one processor specified for it, but then you could hook up a bunch of different hard drives to it. So we would have an array list of hard drives, but we would have, an entry for just one processor. Now that ignores the fact that you could come up with, multi-processor computers. But the vast majority of computers that users buy, implement the multi-processors just as a single chip. That'd be more fun than this. But I already wrote all this stuff. Guess we'll just stick with it. Okay. Now my temptation is to always put these classes in the same file as our client class, and that's bad programming. So I'm going to remove the package statement, move this to the correct place, move to correct folder. Then I'm going to go to my projects, and for my default project where my .java file is, I'm going to make a couple of classes, 3 of them to be precise. One class is going to be a dealership. And it's warning me, don't place Java classes in the default package, but we'll accept that risk. Now go back to our projects and add 2 more classes, the car class and the manager class. So a car. And then one more. Go back to projects, new Java class, manager. Alrighty. I don't remember if we talked about Java doc or not, but this is a Java doc comment here. I'm just going to leave it alone. The authors, my name, your name, whatever. JQ programmer. Who cares? That's not the point. So what does a class have? What does a manager have? Yeah, he has a name. He has a birth date, so that we can remember to send him out a card once a year. Make the dude happy. And then maybe a hire date. We're adding too many variables. Let's just add a pay rate, Does he just get paid on a monthly basis? Yeah. So double.
We can just do a salary.
Yeah. Double salary. Yearly salary, whatever we're going to call it. Now if I was a good programmer, I'd make all these private. I might make a constructor that lets us accept these things. So, private string name, private string b-date. I guess I could write out the whole word, right? Birth date. And then private double salary. Now I need getters and setters for them. I always have strong inclination for just letting refactor do it. If you like to add them by hand, unpause the recording and go to it, especially if you're not using NetBeans or Eclipse. Refactor, encapsulate fields, select all of our fields, do a refactor. Now that adds a million Java doc comments, and it pushes our variables our instance members down to the bottom. I'm going to cut those and move them back up to the top.
Well, this is a C# question. What's the difference between a property and a variable?
In C#, a property is one that has that you can reference as though it had. You can implement getters and setters for it, but you don't access it through get and set. You just use it as though it were an instance variable. Okay. All right, so there's our manager. Let's switch over to our dealership and give ourselves one manager. Manager, lowercase manager. Are we going to instantiate an empty manager with default values? Well, we didn't even make a constructor for our manager class. I hate to take time away from doing that, but let's go ahead and do it because it'll save us time later. So I'm going to make a constructor for our manager class. I flipped back over to it. Public manager. This is our constructor, and it's going to take a name, string birth date, double salary, this dot name equals name, this dot birth date equals birth date, this dot salary is equal to salary. Now when we create our dealership, we could create a default manager, or we could require the client to create the manager and assign it into the dealership. I'm kind of veering towards just wanting to create a default manager. So I'm going to go back to the dealership class, pause if you needed time to actually implement the constructor. So manager, our constructor for the dealership, public dealership. We're just going to implement, we're replacing the default constructor at this point. Manager is equal to new manager, like that. If we feel like getting wiggier with it, we can do that. What have I done wrong? If I spelled manager wrong?
You gotta go back and add the default constructor to the manager class.
Oh yeah. Okay, but I don't want to do that. So let's make the manager's default, just manager name, comma, and then a birth date, 1/1/2001, followed by a salary of 0.
Did you add his hire date in there, or did you just do?
Pardon me?
I said, did you add a hire date, or?
No, I just had.
I just.
My manager type had name, birth date, and salary, and I cut out the other instance variables. All right. Now we probably ought to add a set manager method and a get manager method, so that if we create a new manager, we could do that. Alrighty, so public void set manager, which accepts a manager object. I'm just going to call it other. Then you have to make the decision. Do I want the object to be a copy of what is given to me, or do I want to just reference the object that's given to me? And for simplicity's sake, I'm just going to make it reference the object that's given to me. Is that good programming? Not particularly. We probably ought to copy the manager object as we push it in there. But as long as you're aware of what you're doing. So this dot manager is equal to the other manager that we're passing in. we also know that we're going to need some cars. So let's go to car.java. Private, string, brand name of the car, private, int the number of miles on the car, or double. That's enough. Getters and setters would be a good idea. A toString method. A toString method would be good for all of these. So I'm going to cheat, and I'm going to use refactor encapsulate fields to give me some getters and setters. Then I'm going to cut my instance variables and move them to the top. Pause the recording to take the time to do all that, or to create the getters and setters in your own favorite fashion. I'm just giving it two variables. Normally I give it a make and a model and year and stuff like that. I'm trying to keep this simple. All right, we have a car class. Are we going to give it a constructor? Meh. Yeah, let's do it. So car public car string brand double miles. This dot brand is equal to the brand that we pass in. This dot miles is equal to the miles that we pass in. All right, let's go back to the dealership class and add an array list of cars. So up here in our instance members, array list angle brace car cars. Doesn't know what an array list is, go add the java.util.arraylist as an import. You can always just click on the error, import java lowercase j util.lowercase u array list. Put your name as the author. All right, now back down here. That took care of creating our array list. We don't actually have a new array list. I think I'll do that in the constructor. So cars is equal to new array list, two angle braces, parentheses in parentheses. Now maybe we want a method that's going to print out the manager and print out the array list of cars. That's going to imply that we're probably going to go and add a toString for the manager and the car class. But let's do that. Let's implement public void display. We're just going to display the entire manager, the entire dealership. And should we make this a toString? Yeah. I'm going to leave it alone. No, I'm not. We're going to rough it. toString, public void toString. This is an override, so I'm going to add the override annotation at capital O override. But toString is not a void, it returns a string. My mistake. Public string toString. Now let's make our string. String output, string S, whatever we want to call it, string R for return. TXT, string TXT. It's equal to empty strings, and I'm going to start adding things up to it. TXT is equal to the word manager plus this colon manager. I'm going to put a colon there. And then let's make a separate line for each car. So I feel like adding a slash in. I don't know if a two-string really ought to have all this stuff, but it can be strongly argued that I should just write a display method rather than making two strings serve as our display method. All right, now let's loop through our loop of cars. So for each car C in our cars list, I guess a cooler name would be inventory, txt plus equals that car plus a character turn. And then let's just print out the total number of cars. txt plus equals total cars colon plus cars dot size plus a character turn. So you see what I'm doing? I declared an empty string and then I started just tacking things onto it with plus equals. That saved me from having to write a mega, building them all with string.format all at once. And if I wanted to format each piece, more carefully, I could still use string.format, but for each individual piece that I added on. Now return txt. We have gone far enough that even though we don't have two string methods for our car or for our manager, I'd really like to go to our dealership class, to our client, create a dealership, and then just see what happens. We don't have any way of setting new cars. We don't have an add car method, for example. So this is going to be pretty lame when we actually do it. I'm going to go back to my client and make a dealership. So dealership, Big Joe, is equal to new dealership. Let's set a manager. So we're going to have to create a manager object. Now, let's just print it out. Let's system, before we do anything more, system.out.println this dealership. And let's run it. All right, notice it's just printing out the address of the manager. That's because the manager class doesn't have a two-string, and neither does cars. But it did know that we only had one, that we have 0 cars. So let's add a manager to it. So before our print line, manager m is equal to new manager, and he's got a name. Big Joe is also the manager. And his birth date is 1948, and he earns a huge salary. He gives himself, $200,000 as his salary. Must be nice. Alrighty. And let's add that to our dealership. Big Joe dot set manager equal to m. So you see that since we have an array list of cars, we're not going to just do a set cars. That would probably involve replacing. Instead we're going to do an add car method, and each time they do add, it adds it to our array list. But let's print it out. Let's see if that fixed it. Let's see if that we actually have a manager. No, because we still don't have a two-string for it. We got to go and add our two strings now. So the next thing I'm going to do is flip back over to the manager class, add a two-string. I like putting them below the constructor. Public two-string I like adding my at override annotation. So at capital O override. And it's complaining because I forgot to give it a return type. That's why I like adding at override. It makes me fix everything. Okay, so public string, toString. Let's use return string this time. String s is equal to string s. S is equal to string.format. Or let's do name colon %s space birth date colon %s space salary colon %.2f, and then a comma so that on the next line we can start filling that in with arguments. This dot name comma this dot birth date comma this dot salary, into parentheses and semicolon. Then return s. Good enough. Then we're going to go and compile everything. I'm going to click the little broom and I'm going to run the project. This time, when we call toString on the dealership class, it prints out that his name is Big Joe, his birth date is that, and his salary is that. That kind of looks tacky, but you know, it works. We're getting information out about it. We could get that manager, and then we could, you know, print the information ourselves in our client class and our driver. We're going to need an add cars method, an add car method, and each car that we add to it needs to go into that array list of cars. So there's our toString method. I'll just pause on it for a second. You can pause and type it in if you need to. Now let's go and add a toString method for car. So at override with a capital O. Public string, toString, parentheses in parentheses, open curly brace, close curly brace. Return string.format %s %d, end comma brand, or end quote comma brand miles. You can see toString can be as simple or as complex as you want. That's pretty simple. Alright, it's complaining. I've messed it up. It should have been %f because miles is a floating point. So I'm going to go back here and %f. %s, %f. Now I'm not going to even bother testing it again, although I should to make sure I haven't introduced any syntax errors, so I guess I will. Hit the broom, run it, yay, same output. Obviously our car class ought to have a lot more information. Sales price, you know, stuff like that. Alright, our dealership is the one that has the array list of cars. So we need an add method that will add a car to our array list. I'm just going to stick that above the constructor, even though normally I like to not do that. If I'm thinking ahead, I might like for it to return the car that I just added. I don't know if that's really the case, but I think I'm going to do that. Really, I should just declare it as void. Let's make it simple. Alright, so public void add car, which takes a car as a parameter. Car, uppercase C, car, lowercase c. And then inside that, this dot cars, our array list of cars, dot add the car we just passed in, lowercase c. And just for debugging purposes, why don't we print a message out? System.out.println car added, colon, and then just print out that car that we added. So plus car.
Did we make a two-string method for our car? Yeah, we did. Never mind.
Yeah, we have a two-string method for car, so that's going to work fine. All right, I see that I have a red error here. Is it just because I haven't made things? Let's rebuild everything. Yeah, I hadn't saved it. All right, let's go create a couple of cars. So that's our adder. I'm going to go back to the dealership. No, not the dealership, to my client class. I have too many client drivers open. Let me close everything to stop getting myself confused. All right. Okay. We've set the manager. Let's create some cars. Or let's leave that print line first. This is our empty lot, but now we're going to add some cars to it. Car C1 is equal to new car, and it's a Ford. What is our other value? Mileage? Yeah, 9,000. Ford Explorer. Let's make it look pretty. Car C2 is equal to a new car. I don't know if they make these anymore, but it's a Mazda Miata. End quote, comma. 1, 2, 3, 4, 5, 6 miles. Car C3 is equal to new car Toyota Camry with 50,000, 55, whatever. We've got 3 cars. Let's add them to our lot. What's our lot called? Big Joe. That's our dealership. BigJoe.add car C1 and C2 and C3. If we wanted to write another add method that took an entire array list and then added them all at once, we could do that, but we're not going to bother. BigJoe.add car C2, and then BigJoe.add car C3, and let's print out our lot again. System.out.println. Our dealership was called Big Joe. All right, I built it with the broom. Run it with the green arrow. Pause it if you need time to type all that, because I'm going to scroll up and look at the output, I mean. There we go. Here's our original lot before we did anything to it except hire the manager. Then we added a car to it, we added a car to it, we added a car to it, and then the next time we print it out, we have our manager and we have our 3 cars. All right, so this is composition. Doesn't use any aggregation, right? Because we don't have anything that's shared between more than one lot. But it is composition. One dealership has a list of cars and it has a manager. So it's composed of a list of cars and a manager. Now let's check their slide to see how they did this. All right, their dealership consisted of a company and of a manager and an array list of salespeople. I know you can't read this unless you zoom in. And an array list of cars. They made a constructor for it that takes a company name and a manager. They added a couple more methods, an add car method, just like we did, that calls car.add, that it appends something to the array list of cars.
Where is that cars Where's that array list stored at?
Right here. It's part of the dealership.
So even though the car class is in its own class, like file, it can still reach the dealership's cars list?
Right. We haven't seen how they define the car class yet. But yeah, the dealership is composed of several items, and one of those items is an array list of cars, just like we did it in our example.
I just didn't see how they added it to a whole nother classes.
Well, it's an array list of cars. So how do you add to an array list? You call cars.add. Just like you were going to add to any array list.
Right, but the car class is a whole different class. How are they adding to? That's what I don't understand.
They're creating a new car and then adding it.
Okay.
So just like we did, we created cars C1, C2, and C3, and then we added each one.
Mm-hmm.
They're going to be doing the same one.
Okay. Gotcha.
So then they printed the status, which we were using for toString. Then they had a car, which had, all they had was a make. All right, cool, made it easier for them. And then a manager, all the manager had was a name. See, we were more ambitious than they were. Salesperson, they had a name and then they had a sales to date. So there was 2 pieces of information. Notice their constructor, though, only accepted the name. I guess that's appropriate. You construct somebody, you're not going to give them sales, before they sell anything. Then they made a dealership driver. They created a new manager. They created 2 salespeople. Then they created the dealership passing in. Nope, they didn't pass in anything. They created a new dealership, and the constructor accepted a name and a manager. But then they had to add salespeople to it. Then they started adding some cars. Add car, new car Accord, add car, new car Civic, add car, new car CRV. Then they printed its status out. Very similar to how we did it. All right. I don't want to take too much longer on this, but I want to brush upon the idea of inheritance. That's composition. Completely different concept than inheritance, really. Inheritance is a composition is a has a, dealership has a manager. Inheritance is when you define a root class, a base class, and then you inherit from that class, adding functionality to it. Now when you hear the word superclass, which is how they refer to it in Java, it doesn't mean that the class is more powerful than the rest of the class. It just means it's the one that's at the top of the inheritance list. So we have a generic person class. It contains data and methods that are common to all classes in the hierarchy. Then you make a customer class. The customer class inherits, or in Java is known as extends, but it inherits from the customer class, adding a new value to it, the string. The employee class also inherits everything from the person class, but it adds a new value to it, integer. Then they made 2 more classes. A full-time employee has a salary, whereas a part-time employee has an hourly wage. So a full-time employee is an employee, so it has everything that an employee has, who is a person, who has everything that a person has.
Is this a silly example, or is this usually how they do this? Like, would they not just make an employee class and then have full-time, part-time, or would they actually make a person and then
yeah, when do you use this? You use this when you want to start implementing polymorphism, which is where you want to start storing a whole bunch of people into the same list. You declare that an array list as an array list of persons, and then you can just recklessly start storing customers and employees and full-timers and part-timers into it.
I see.
So within an inheritance hierarchy, pairs of classes are linked together. For each pair of linked classes, the more generic one, the one higher on the list, is the superclass. The more specific class is called the subclass. And we say that subclasses are derived from the superclasses. The keyword that does that is called extend. Unfortunately, the terms superclass and subclasses are misleading. Super implies that it has more capability, and that sub implies that it has less. It's the other way around. Since each subclass adds more functionality to the superclass, they have more powers. Subclasses can do everything that the superclass can do and more. So we'll stick with the terms superclass and subclass since those are the formal terms, but be aware of the alternate terminology. Programmers often use the term the parent class or base class. And if you have a parent class, then the classes that inherit are called the child classes or the derived classes. I kind of like parent class or child class. I also tend to use base class. Let's skip a little bit here and make an itty-bitty series of inheritance. Now I am going to be a bad programmer and just tack those onto my driver class, my client class. So the one that I had with main, I'm going to create a couple of more classes. So we're going to define a generic class called Pokemon. Shouldn't call it generic because that's actually a different term. Now you can actually only have one class, one public class per file. So the rest of these are not going to be public classes. I just use class Pokemon. And I can't even think of what every Pokemon has. Let's give them hit points. Int hit points, or HP. That's enough.
Name and type, I guess.
Yeah, everyone has.
Just give it a name. I mean, because I just.
Yeah, that's a good idea. Let's give every Pokemon a name as well. Because, yeah, every Pokemon's going to need a name. So now let's define one called a fire type. That extends the Pokemon class. So every fire type is a Pokemon.
Okay, so if we're going to do this, does the Pokemon class need a string type, I guess I could say? And then you set the type equal to...
No, because that's is a relationship. Every Pokemon is a fire type. Instead, we're going to build a vice versa. We want to do a has a relationship. No, we don't. We want every Pokemon every fire type to be a Pokemon, so that's an is a relationship.
Right. I wasn't meaning to set the string type in Pokemon to fire, just string type, I guess I could say.
Yeah, we would go in that direction of giving the type, putting it into the Pokemon type once we start defining interfaces. Let's go ahead and do that. I'm kind of reluctant to do this, but let's go ahead and give our Pokemon a type. So when we create a fire type, we need to set his type to fire. So we're going to give him a constructor. Public fire type and what it does is it sets this dot type equal to fire. Now let's make one more. I should start trying to conserve space by putting the braces, on the same lines, just because I don't have as much space as y'all do on your screen. we're going to make a Charmander, who's a fire type. So class Charmander, who extends the fire type. In his constructor, public Charmander sets the name of the Pokemon to Charmander. So public Charmander, parentheses, square brace, this dot name is equal to Charmander. Now I'm going to go back and add a toString method to the Pokemon class that prints out its name and its type. Now none of these have actually set the hit points for the Pokemon. Maybe we should add a method to Pokemon to allow us to set the hit points for it. But this will be good enough. Maybe we will. Let's do that. Void set HP that takes an integer. So void set HP, I'm going to capitalize HP there, int HP, and it sets this dot HP equal to the HP that's set in. So this open brace, this dot HP is equal to HP, semicolon, close brace. Now let's set, or excuse me, let's add a toString method to the Pokemon class. Public string, toString, open curly brace, return string.format, the name of the Pokemon. Well, we better build a formatting string. Name equals %s, HP equals %d, and we need to fill those in with the name and the hit points. Now I'm not going to show you calling the class's superconstructor. Let's see if we can get away with not having to do that. So once we're done typing all this in, we're going to scroll down to main and create a fire type Pokemon and see if it populates all the other data types, if it fills in the name and the hit points. Oh, I didn't print out the type, did I? Name is equal to %s. I'm going to add this to my string format. Name is equal to %s. Type is equal to %s. HP is equal to %d. Now I've added so many things that I'm going to put a carriage return here. And what I'm passing to it as arguments are name, comma, type, comma, HP. And I really like adding this in front of everything. So this dot name, this dot type, this dot HP. All right, we're going to need to wrap this up, but I do want to give it an actual try. So I'm going to go down to main, my driver, I'm going to create a Charmander. Charmander, char. No, can't use that. Charmander Poke1, Poke1 is equal to new Charmander. And then let's try to print it out. System.out.println Poke1. So we're going to call the toString method on the Pokemon class. Now notice the Charmander doesn't have a toString method. The fire type doesn't have a toString method. So it's going to have to run all the way up the hierarchy to run the Pokemon's toString method. Let's see if it works.
With it doing that, does it, I guess my weird question would be, does it make like the the program's runtime longer happen to run up and get that, or is it just? I mean, I know nowadays it's so fast it doesn't.
Right. Does that lower the performance of it to arrange it in this fashion? I suppose it might slightly, just because it's managing more references, and each dereferencing of an address is another additional step. But I don't really think that it's going to have a serious impact. All right, I didn't set the Pokemon's hit points. So Charmander poke 1 is equal to new Charmander, and then poke 1 dot set HP. He's got 100. And then system.out.println Pokemon. Now, if you're unfamiliar with Pokemon, I hope this example made some sense. You know, just think of it like you have an animal class, and then you have a canine class, and then you have a dachshund class. You know, you're going from the least specific to the most specific. Run it. See how it went? Scroll up my output. Oh, I never did run it. I just built it. All right, and I did get a Charmander who has a fire type, who has a hit points of 100. So notice what happened. Since we had default constructors, it all worked cleanly. When we created a Charmander, it ran up here and ran the Charmander constructor to set the name of it to Charmander. But then that also invoked the Let's add some print lines to see in what order these constructors work, and then this will be the very last thing we do. So after public Charmander, I want to do a system.out.println making Charmander, right? We're calling his constructor. I could even say constructing Charmander. Constructing Charmander. Then come up here to fire type and do the same thing for fire type's constructor. The first line of that, system.out.println constructing fire type. And I forget if we had a constructor for the Pokemon class itself. If we did, no, we did not, so I'm not going to add one just to prove this point. But when I run it, in what order are these constructors called? Let's find out. So I run it, constructing fire type, and then constructing Charmander, from the least specific to the more specific. And if, I don't know why I can't say that, specific. And then if we went up here to Pokemon and we added a constructor, that would have been the very first thing invoked. So it runs up the hierarchy, it runs his constructor, and then it runs the Pokemon, the fire type's constructor, and then the Charmander's constructor. Now if you need to invoke a different constructor, like parameterized constructors, these were all very simple, right? They didn't accept any parameters. There's a keyword you use in order to invoke, you know, your parent's class, your super class's constructor with the parameters that you need. All right, I think that's enough. We have talked about composition, and we have talked about inheritance. I think we've gotten a good start on this.
Can you save the, like after you accidentally save the project to a certain spot, can you save the entire project to a different spot instead of just saving a file at a time?
So we had a question, can we move the project somewhere else? If I come over to the project list, click on my project, right click, move it to a new place. That's how you would do it if you want to move the entire project. Right click on the project name in your projects list and choose move.
Okay.
Alrighty gang, I hope this was interesting, and I'll see you next time.